Hello everyone, welcome back. I hope everyone is doing great. My name is Ravi Teja. Let's solve today's Leetcode problem 1009 complement of base 10 integer. The complement of an integer is the integer you get when you flip all zeros to ones and all ones to zeros in its binary representation. For example, the integer 5 is 101 in binary and its complement is 010, which is the integer 2. Given an integer n, return its complement. Okay, so we know every integer number fits in 32 bits. Okay, so one solution would be straight away generate its binary representation. Okay, once you got its binary representation, flip all the characters and then convert it into its 2's complement. Okay, so this approach will also work for the given problem statement and all the test cases will be passed and it will be pretty efficient solution as well. So we will be taking an extra space. Okay, so I will just show you the implementation. Okay, I have converted the integer n into its binary representation. Okay, by using the inbuilt methods, or else you can also generate the binary representation. Okay, now that I have its binary representation, I have to flip the characters and then I have to generate. So at runtime I will be flipping it. Okay, so I would start from the end. Okay, if it is 0, then its complement would be, if it is 1, then its complement would be 0. So I will be taking the at at a particular position and then left shifting it by its corresponding value. So this has a power of 2 power 1, this has a power of 2 power 2, and so on and so forth, right? So when I left shift it's by a particular number, the number will be incremented by its corresponding power. So bit is basically the position at the value at the corresponding position, and then I am left shifting it by a certain number which will give its corresponding 2 to the power, right? And then I am just doing OR. Okay, so I am going in the reverse direction and I am getting each positions. I am flipping the character, flipping the bit and getting its binary equivalent of 2 power, and then I am doing OR to my answer, which will be adding all the values and then I'm returning my answer. Okay, so this is basically the brute force solution where you will, the time complexity is basically the number of set bits in the number of bits in n, and the space complexity is also the number of bits. Okay, so it will be big O of log of n and big O of log of n, both in terms of time and space complexity. Okay, now we can actually do better in both time and space complexity. Okay, if you see 5 is basically this, right? The binary representation of 5 is this. Now we have to flip it. Okay, now we want to flip only these characters, right? So if I simply take the negation, that will flip including all its leading zeros as well, right? If you say I'm flipping it, the leading zeros are also getting flipped and also the desired bits are also getting flipped. Now I should only preserve the bits of the initial size, right? Only these bits I have to preserve. So how can I preserve only these bits? Okay, if I can generate a number with all ones, right? If I have a number with whose binary representation is all ones of the same length, and if I do and only these bits will be preserved, right? So how can I generate a binary number with these many ones, right? So if I know the size of the number of bits I have in the original number, okay, the number of bits in the original number are 3, right? 101. I am not considering the leading zeros, I should only consider these things. Okay, if I know the number of bits I have, then if I simply do left shift of those many bits minus 1, that will give me this number. Okay, so the number of bits I have here is 3. 2 left shift 3 is 8 minus 1, which is 7, and 7's binary representation is this, right? Now all I have to do is to do AND of these two operations. Okay, so what is this? This is negation of n, right? And what is this? This is the number which is formed by left shifting 1 by the number of bits. Okay, so the number of bits can be derived as the 32 minus the number of leading zeros, right? So integer has total 32 bits. I have a inbuilt function which will tell me the number of leading zeros, so you can simply get it. And if you finally do and of these two numbers, then that will give you the answer. Okay, you can also find the number of bits using, you can write your own code as well. You will simply do left shift the original number as long as it is greater than 0. That will also give you the number of bits you have. Okay, in the end you need the number of bits, and then you will be left shifting it by those many bits, and you will be subtracting 1, and then whatever number you get, that number you will do AND with the negation of AND. Okay, this algorithm, if you go with this approach, the time complexity will be constant, and also the space complexity is also constant, right? So if you are, this might take log of n if you are writing your own algorithm to find the number of set bits. So this might take big of log n, and these two are like constant operations. Okay, so that's all about this problem. If you like the explanation, hit the like button and hit the subscribe button. I will be posting solution in multiple languages such as Java, JavaScript, Python. Feel free to check it out. I have also started a play series where I have posted the Leetcode dynamic programming study plan problems. Feel free to check it out. Thank you.